Thanks, Nathan. First, I'd like to thank the Soil CRC for sponsoring my research and for allowing me to present some of my findings to date. I'd also like to thank my supervisors, because without them, I wouldn't have got past square one. So, at the outset of my research, I spoke to the Wimmera CMA, and they identified that soil organic carbon is particularly of interest, particularly in broadacre farming. Now, I'm a computer science engineer, computer systems engineer, as Nathan has already outlined, and the central tenet of engineering is if you can't measure it, you can't control it. Measurement of soil organic carbon is expensive, and the results aren't immediately available. Now, remote sensing provides the possibility of estimating soil organic carbon using reflected light. Some satellite images are free to use for both research and commercial reasons, so the data is available for free. Combined, this allows for fast, frequent and transparent estimation of SOC. My ultimate vision here is for the ability to measure soil organic carbon at a scale of every 100 square metres of the country, updated every 5 days as a continuous process. Now, I'm not nowhere near there yet. And there are some issues with this. First of all, it's an estimate. It's never going to be a measurement. So the gold standard will always be measurement. The estimate is only going to apply to visible topsoil, not soil at any depth. Where no-till practices exist, you can't see the soil from space. So that's going to be an issue. And we've got some ideas around this, some short-term ideas and some long-term ideas. So we're not dead yet on that front. What we do need, though, is a sophisticated but lightweight model that allows us to estimate and process images and reveal soil organic carbon values. So this is where we're at with a lightweight convolutional neural network. We're getting technical here. The benefit of this is it's only got 7,500 parameters in the model. Compare and contrast that with something like ChatGPT-4, which has got 1.7 trillion parameters. So this is lightweight, because the last thing we need is to need a supercomputer to do this estimation. Quickly, there's 13 bands of light coming into the model. The first stage looks at the peaks and troughs in that data form and identifies which of those peaks and troughs are important. It then identifies in stage 2, which are the important combinations of those peaks. And the final stage determines which of those combinations are important. During training, the way this trains is that parameters are updated by determining the difference between the estimate being produced by the model and the actual ground truth, and it updates the parameters to get that right. Now, this last bit is not satisfying to me because it doesn't include anything about the soil science. It's only looking at the data. So I've changed it around a little bit so that as well as looking at the data, it's also considering what we know about the soil science itself. The trouble is that soil science is not the same as other more regularised disciplines, soil being cantankerous, so the relationship between soil carbon and light is only partially holds true because of all the other parameters, and I'm running out of time. How does the model go? The model is pretty accurate on some Lucas data set. We found that it also is fast. The estimates, once the model was trained, for all 6,000 samples took 0.2 seconds for all 6,000 samples on a laptop. So it is lightweight. How can this help? If we can get satellite images from bare soil, we should be able to estimate soil organic carbon reasonably frequently. If there's no bare soil, maybe we need to go to proximal sensors. In the short term, in the long term, I've got some ideas. And if we're using proximal sensors, we can then use the same technology to estimate it at multiple depths. And so there's a potential for a monitoring tool for farmers to be able to convert multispectral images or hyperspectral images to SOC estimation at a scale of 100 square metres every 5 days. And this might be something that NRMs might be able to roll out to support their communities. Thank you for listening.